Hello students, welcome to Board Maths Made Easy. In previous videos we learned the concepts and also we have done the exercise 1.1 question number 1 and 2, and in this we will continue from the next question onwards. I think we have done the question number 2 also, so we will continue from the next question onwards. So in this question they are asking to find the LCM and HCF by applying the prime factorization method. So prime factorization, you know it how to do that. So how we do it? 12 we can write it as 12 it is a divisible by 2, so we can write it as 2 into 6 or 2 into 3. So these are all the prime factors. Similarly for 15, first we need to do the prime factorization, then we will take the greatest common factors or the the product of the either greatest prime factors or the product of the least powers of the prime factors. Okay, so using that method we will find the things. We will write that, don't worry. For now we will concentrate on prime factorization. Here 15 I can write it as only 3 into 5, and 21 I can say it as a 3 into 7. So the common prime factors in all of this is only 3, and overall prime factors are involved are 2, 3 and 5 and 7. So for LCM we know it is always write this definition, it is easier. Greatest product of the greatest powers of the, you have to consider greatest powers of the factors of the prime factors. We don't write here anything common. Okay, product of the so in 12, 15 and 21, what is the power of greatest powers of 2, 3, 5 and 7? Okay, here it is 2 square, this is 2 square into 3, so that implies we can take LCM is equal to product of the greatest power 2 square for 3 into 5, and here everywhere the power maximum power here everywhere possible is only 1. So 3 into 5 into 7 is the LCM, that is 4 into 5, 20, 20 into 360, 420. Correct? Similarly, if you have to find the highest common factor is what actually? The definition says product of the least powers of common prime factors. Remember, this definition only can tell you what exactly you need to consider. So if you know that much definition, it is pretty easy. So here in this 2 square comma 3, the common among all of this is 3 only. So HCF is now simply 3 only, that's it. So there is nothing much we need to do here. So HCF is this much and LCM is this. So what is asked in this question actually? Find the LCM and HCF of the following by applying the prime factorization method. So we found the LCM, we found the HCF. To make it a simpler representation, we can say LCM of 12, 15. Remember, this is a notation where we can represent everything like this. LCM of 12, 15, 21 is equal to 420, and in the next line you can write HCF is HCF of same 12, 15, 21 is equal to 3. That's all. You got the answers. So next part of the question is finding the same things for 17 and 17, 23 and 29. Okay, so let me 17, 23 and 29. For this also we need to find. If you look at this, you can clearly say, does 17 has any factors? Let us write prime factors for 17. I don't see anything. So 1 into 17, no, these are the only possibilities. 23 also 1 into 23, and for 29 1 into 29 only. So there is no other because 17, 23, 29 are not composite numbers. Okay, that is the reason. You know what are composite numbers means. Other than 1 and 2, the number itself, if there is any other factor, then those are all composite numbers, otherwise they are prime numbers. So in this, the same rule. What is LCM is? LCM is product of the greatest powers of the prime factors. Here greatest factors, in this case 17, 23, 29. Okay, 17 power 1, 23 power 1, 23, 29 power 1. So LCM of 17, 23, 29 is what? Definitely 17 into 23 into 29. Clear to that part? Now comes the tricky part, highest common factor. See what exactly by definition is a product of the least powers of common prime factors. Or you can say sometimes instead of prime, sometimes because certain numbers have no prime factors, because 1 is not a prime factor. Okay, that is the reason it's not a prime number. That is the reason in this case, what is common among all these three? HCF of 17, 23, 29, it is only 1 is the common value. That is the reason LCM of this number is 17 into 23 into 29. When you multiply, you will get a bigger number, like something like 11,339. Okay, similarly highest common factor is 1. Remember, if you recall from our previous sessions, HCF can divide each number, and similarly LCM can be divisible, it can be divided by the given numbers. So LCM will always greater than the any of the given numbers. Similarly HCF is, it can divide any numbers, any of the given numbers. Okay, so LCM, this we can divide with the given numbers like 17, 23 and 29, whereas HCF can divide all the given numbers. So 17, 23, 29 all can be divided by one number called HCF, and that HCF here there is nothing common, so 1 is the only factor. Okay, next part is find the LCM and HCF for 8, 9 and 25 using the prime factorization method. 8 can be written as, I can write it 2 into 4 or 2 into 2 into 2, that is 2 cube. 9 I can write it as 3 into 3, and 25 I can write it as 5 into 5. Correct? So these are all prime factors. That means simply this is 3 square, this is 5 square. Here also there is no common prime factor among all of these things, or common factor. So LCM, as per our definition, it is the product of the greatest powers of the prime factors. Product of the greatest powers of the prime factors. So here there is nothing common. Okay, we don't write when they in the LCM. We just consider only the highest possible power in all these numbers for any given factor. So if you write that, this is 8 into 9 into 25. So 200 into 9, that is 1800. Okay. Similarly, highest common factor. If you look at this as is, there is no it is a product of the least powers of the common factors, but there is nothing common, so they all will be like 2 cube into 1, 3 square into 1, 5 square into 1, or simply 1 into 8, 1 into 9 into 1 into 25. So 1 is the common factor. Okay, so LCM and LCF we found. So this is the question number 3 with all the 3 parts we have completed. Okay, next question says, given that HCF of 306, 657 is 9, find LCM of 306, 657. If you recall, there is a formula HCF into LCM or HCF into LCM of same numbers. Okay, if here we are showing 2 numbers, here we are showing 2 numbers, these numbers should be same, otherwise it will be not applicable, this formula. So for these 2 numbers is equal to the product of the numbers. This is the rule we know, correct? But here what he has given, 306, 657, highest common factor he has given as 9. So 9. We need to find LCM. Into LCM of these numbers, 306, 657 is equal to this. So what is LCM? Simple. You have to divide 306 into 657 divided by 9. What this will give? So 9 3s 27, 9 4s into 657. So the product will give you the LCM. So when you multiply these 2 values, you will get the value 22,338. So you have to do that multiplication. Okay, so I have done it separately and I have written the value. Okay, the next question is 5th one. Check whether 6 power n can end with the digit 0 for any numerical n. That means if you say 6 square, 6 cube, 6 power 4, etc., for some value of n, does that number end with 0, that product? So for any product to end with 0, it should be having the factors 2, 5. Why? Because 2, 5 gives the 10, and any product, the final result, if it is having 0 as the last digit, that should be definitely divisible by 10. That means the prime factors should be 2 and 5. So that means if 6 power n can end with, if it can have 2 and 5 as prime factors somewhere, okay, there may be other factors, but if that contains 2 and 5, then only the number can be divisible by 0. I mean, the number can be ending with the digit 0. So what I write here as a solution, to end with the digit 0, the number should be divisible by 10. The number should be divisible by 10. So to be divisible by 10, it should be factorized with 2 and 5. But in 6, we can clearly say that you take 6 power n. So 6, how can I write? See, something value ab power n, if it has factors, then you can write like this, a into b whole power n. So this will be, whatever be the value of n, irrespective, the prime factors will be only 2 into 3. So that will be always like 2 power n into 3 power n. You do whatever be the value of n. So since 6 does not contain 2 and 5, since 6 doesn't have 2 and 5 as prime factors, okay, this number can never end with as prime factors. This number can never have this number means what number? This number 6 power n can never end with digit 0. Here we are trying to not just tell the solution, but we are trying to write in a proper terminology which are essential for CBSE board exam. And by visual itself I can tell you certain things, like suppose if your 6 is there, 6 square is 36, again it is ending with 6, and when you multiply with another 6, that means 6 cube, again the last two digits will be 6 into 6, that means again another 6. So any number, okay, n, the power of in the power of 6 power n, whatever be the value of n you take, it will always end with 6 only, and n will be always greater than 0 and positive number. Okay, so 6 power n to any positive power, okay, the value will always end with only 6. Of course that we don't write here because we need to prove only when there is a factor 2 and 5 as prime factors, such numbers can end with values 0. Okay, the next question, sixth one is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 21 plus 5 are composite numbers. If you recall the definition of the composite numbers means their product should be of any factors which is greater than 1. Composite numbers will have more than 2 factors. What are those 2 factors? The number 1 and the given number itself. Composite numbers will have always factors, prime numbers will be always having factors 1 and the given number itself. Composite numbers will have factors other than 1 comma given number comma some other factor, given number and other factor and other factor. That means they clearly say that more than 2 factors if any given number has, then it is called as composite number. Suppose you take 8, 2 into 2 into 2. So here 1 is there, 8 is factor and 2 is also factor. Okay, because here we have 3 factors, 1, 8 and 2 possible factors. So if there is a greater than 1 and not the given number itself, then that is called composite number. So here, or simply we can say this way also, if there are 2 factors above 1, that means one factor may be the given number and another factor is existing, like in case of 8 we said 2 and 8 are also factors apart from 1. So such cases we can say that is a composite number. So in these given examples, how we can confirm? So 7 into 11 into 13 plus 13, if I write like this, 7 into 11 into 13 plus 13, okay, we can do that numbers, like you can do summary, like total what is the actual value you get, and then you can redivide that into factors. That is one way, but we don't want to employ any complex methodology. Here in this given scenario, I can see 13 is common in both, 7 into 11 into 1 plus in 13 I will take 1. So this is 77, 7 into 11, 77 into 1 plus 1. So for me it appears 13 into 17 into 1 is 17 plus 1, 18. Sorry, this is 77, not 17. Okay, 7 11s are 77 plus 1, 78. So here there are 2 factors above greater than 1. So what I can say, this is a product of 2 integers, this is a product of 2 integers or 2 numbers. Okay, 2 integers, both 13 and 17, 78, both greater than 1. Therefore the given number 7 into 11 into 13 plus 13 is a composite number. The proof of a composite number is simple. There should be at least two factors and they should be greater than, both should be greater than 1. That's it, simple. Then the next part in this question. So the next part of this question is a 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. 7 into the next part. Okay, let me take 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. This is exactly similar to what we have seen in the previous problem, correct? Here we have 5 as common factor. I can take 5 as common factor. Then 5 into 7 into 6 into 4 into 3 into 2 into 1. Okay, I am not writing 1. If you write also no issues. Plus 1. This one is important. Why? Because this is coming from by writing this as 5 into 1. Here we have 7 into 6 into 5 into 4 into 3 into 2 into 1. So that part is this. So how we can make this summary? If you multiply this number, okay, 2 4s, I think I will do some rough mathematics somewhere. The calculation 7 6 are 42, 42 4s are 168, 168 into 6. So that will give you roughly like 168. Okay, 5 into 1008 plus 1. Okay, the product of this is 1008. That means this is 5 into 1009. So here we have two factors which are both greater than 1. This is again, see, irrespective, you need to write this terminology each and every question, because board look for these kind of statements. This is what is this? This means 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a product of two integers. Okay, it may be 2 or more, but we don't bother about them. Okay, of two integers 5, 1009, and both are greater than 1. Therefore, the given number, what is that given number? 7 into 6 into 5 into 4. This you need to write always. 3 into 2 into 1 plus 5 is a composite number. They look for this, whether you have done this maths or not. Remember, whether you have done and this is there. Okay, if that is there and you write this statement, this is a product of two integers 5, and you don't need to underline everything. Okay, there are certain problems, certain formulas where we need to box or underline, etc. But in this case we don't need to do any big underline, and most often the questions will be within the 2 marks range. Very rarely you may get a 3 marks range, and don't expect 4 and 5 marks will come. That kind of questions won't come in this particular chapter. There is a 7th question which is application based. Okay, that is very important to understand. Okay, let me write it on a new paper, that particular question. I will write and then capture that. Okay, this is the question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. That means Ravi is a bit faster compared to Sonia. And here our focus is not about the who is running fast or who is driving fast. Okay, so they just gave information. Suppose they both start at the same point and at the same time in the same direction. After how many minutes will they meet again at the starting point? So what you need to see, they can do 2 laps or 3 laps or some laps. Okay, so they will have again a connecting point where both of them will meet. Like suppose Ravi is able to complete 3 rounds in 36 minutes. Okay, just based on my thinking, I'm saying that. And Sonia takes 2 rounds in 36 minutes. So after 36 minutes both of them will meet. Here you don't deduct a value like that directly. That is unnecessarily you are breaking your head. So the easiest way is, if you remember HCF and LCM, which one is the more suitable case here to find? In case of LCM, every given number can divide the LCM and it will give some integer. Similarly, in case of HCF, the given values will be the highest and HCF will be always the lowest one. Here they can't meet in the first round itself. They have to take more time. More time means LCM will give you LCM of two numbers, LCM of any two numbers or three numbers. Let us say LCM of A comma B is greater than always individually A and B. So A can divide LCM, B can divide LCM. So here we need to find the LCM of 18 and 12 or 12 and 18. So what is the same where it has come the problem now? It has come to our finding the prime factorization and find the LCM. So the LCM of 18 and 12 gives you after how many minutes they will again at the same point. So remember, if there is no integral LCM you are able to find, you will find always. Okay, you may give the rules. If you recall the rule, what is the rule of the LCM? LCM is the greatest power, product of the greatest powers of the prime factors. Correct. So you take that. If you are not at 36 minutes, if something else is given, they may meet at a different like instead of 18 and 12, suppose if somebody is doing at 15 minutes, somebody is doing in 12 minutes, then we will find LCM of the 15 comma 12. Here I am just for example, this is only another example, but don't do this one in this case, because here we have given only one is taking 12 minutes, one is taking the 18 minutes. So LCM of 12 and 18, 12 factorization is 2 into 6, that is 2 into 2 into 3, that is 2 square into 3. Okay, and for 18 I can say this as a 2 into 9, 2 into 3 into 3, that is 2 into 3 square. And by definition of the LCM, LCM is the product of the irrespective in any case, unless it is a just what do you say ABCD optional multiple choice questions. Other than that, if it is a you are going to write a descriptive answers like this, you write this one. LCM is equal to product of the highest powers or greatest powers. You can write any term, highest powers of the highest or greatest, doesn't make any difference, highest powers of the factors. Okay, usually they will be prime factors only. So here in this case LCM of 12 comma 8 will be then product of, that means multiplication of the highest powers. In this highest powers is 2 square and in this highest power is 3 square. Okay, so 4 into 2 square is 4, 3 square is 9, 4 into 9 36 minutes. So after 36 minutes both of them will be meeting at the same point. So this is exercise 1.1, and in the next video we will continue with exercise 1.2. Thank you.